Okie dokie, here we go. All right. So today we are doing word problems with right triangle trigonometry. And I am going to do problems 2, 7, and 8 with you today. And then give you a chance to practice some of the same types of things. The math is the same. It's still right triangles and trigonometry, sine, cosine, and tangent. We're just adding the new layer of sharing that in a word problem. Okay. So I am going to start off with question number 2. Right. The way I do word problems is I read it the first time through just to get kind of a little bit of an idea of what I'm talking about, and then I read it a second time through to try to pick out the details. If it takes you more than 2 times, that's totally fine. That's just what works for me. So question number 2, an electrician leans an extension ladder against an outside wall of a house so that it reaches an electric box 25 feet up. So in my brain, I'm like, okay, there's a ladder, there's an electric box. All right. The ladder makes an angle of 60 degrees at the ground. Find the length of the ladder. Round your answer to the nearest tenth of a foot if necessary. Now, this question provides me a picture, so I just need to fill in some of the blanks. All right. So, the electrician leads a ladder against the wall. If it's helpful to you, you can always label the picture. Have fun. You can always label the picture, right? This is the ladder, right? And then this is the wall. This is the electric box up here. Maybe this information helps you see it a little clearer. Maybe it doesn't. The electric box is 25 feet up. So you'll see the 25 is already on this vertical distance. And the ladder makes an angle of 60 degrees with the ground. Okay, so ladder, ground, ladder, ground. So this is going to be 60 degrees. Find the length of the ladder. It's already indicated with an X for us. Now, I'm going to label hypotenuse, opposite, and adjacent, but I've got to pick whatever angle that I'm standing at, right? I've got to pick my reference angle. Where's my perspective? It cannot be the right angle, so it's either going to be the one that's labeled as 60 degrees or the one that's blank up here, whichever one you want. I'm going to choose to just go with the 60-degree angle, and so I'm going to kind of visualize that I'm standing down here at the base of the ladder. And from there, I'm going to label hypotenuse, opposite, and adjacent. I know my angle. 25 is the opposite, I know that, and I'm looking for x, my hypotenuse. So I'm asking myself, which function uses the opposite and the hypotenuse? Make sure you know how to spell SOHCAHTOA for your test. So opposite and hypotenuse is going to be the sine function. So the sine of the angle, this time it's 60 degrees, is equal to, the opposite comes first, so that goes on the top and the numerator of my fraction, and x comes second, so that's going to go in the denominator. Since my variable is in the fraction, I'm going to crisscross multiply to solve. So I get x times the sine of 60 is equal to 25 times 1 I want to get x by itself, but I have a sine of 60 in the way, so I'm going to divide by the sine of 60. Whatever I do to one side, I've got to do to the other. And then here's where your calculator work comes in. So in your calculator, you need to do 25 divided by the sine of 60. I'm going to leave a few extra decimal places And then I like to go back and reread. Oh, what am I rounding to in this problem? It says round your answer to the nearest 1/10 of a foot if necessary. Now, when a question is asked in whole sentence form, then I'm going to enter in a whole sentence form. And so I'm going to write a complete answer here that asks me to find the length of the ladder. So my response is going to be the ladder is, and I'm going to round this to 1 decimal place. So the 0.86, 6 is going to round my 8 up into a 9. So 28.9 feet long. And that's going to be my complete answer. Anything that I can answer or clarify on this question? Okay. All of the problems on the front of this worksheet have a diagram for you. All of the questions on the back do not have a diagram, which means we have to create our own. Before I jump over to question 7 and 8, I want to talk about some of this vocabulary here. I know, my pictures are just epic. But we have these two vocabulary ideas that we're going to use. And one of them is the angle of depression. One of them is the angle of elevation. All right. Angle of elevation. If my eye, let's say I'm 5'4", let's say my eyes are exactly at 5 feet. Sure, maybe they're close. Okay. And if I'm looking straight out, that's not going to be at an angle. If I am looking up at something, the top of a tree, a plane, a balloon, like whatever, I'm looking up, that creates an angle of elevation. And so that's what I have kind of depicted here in the red type. Angle of depression is if I'm up top and I'm looking down. So if I'm on top of the roof and I'm looking down just to wave at my friend on the ground, or if I am, on the 4th story balcony in a hotel looking down at the pool, like something when you're on top looking down. And that's going to create an angle of depression between whatever your regular eyesight is down towards wherever you're looking. So we're going to need that. This is spelled wrong. Elevate. Yikes. Elevation. Elevation. That's better. Okay, cool. So, looking at 7 and 8. All right. I'm going to draw a picture here. It's going to be super duper like 3rd grade status because I don't practice my art and it's not something that I work on. And it's also going to be like a sketch. It's not going to be drawn to scale at all. All right. Are you ready? See how bad this gets? Okay. First reading through. A boat is heading towards a lighthouse whose beacon light is 150 feet above water. Okay, I have a lighthouse. And there's a boat. The boat's crew measures the angle of elevation to the beacon, 4 degrees. That's very small. What is the ship's horizontal distance from the lighthouse and the shore? Round your answer to the nearest 1/10 of a foot if necessary. Okay. So what do I have? I've got a lighthouse. I'm going to draw a lighthouse. I don't know how to draw a lighthouse. Bear with me. Lighthouse. Definitely has a door, right? And then it's going to have lights up here. What does the light look like? Somebody help me. Lord almighty. Okay. It's like a big spotlight, right? It's shining. That looks like a submarine. It's perfect. Okay. So I have a lighthouse. It says that the lighthouse is 150 feet above water. All right. And I've got a boat. You want to see how my boat's going to be even worse. Are you ready? Okay. Boat. That's my boat. It's so tiny. It looks like a petri dish with a flag from the golf course. It doesn't have to be good to be accurate. Okay. All right. Now, whenever you're drawing these pictures, remember, like, okay, whatever I've got there. We are talking about right triangle. So I'm going to make a right triangle fit into this picture. So I have a height here I come out to this boat, there's some angle, right? So make a right triangle fit in your picture. Find out where the right angle goes, right? We hope that that lighthouse meets the ground at a 90-degree angle. That's the goal. And then fill in the other pieces of information. The beacon on the lighthouse is 150 feet in the air. The boat's crew, so if you're on the boat, I'm going to draw a person on the boat. They're going to be gigantic compared to the boat, and that's okay. Here I am on the boat. The beacon's crew measures the angle of elevation. So looking up at the lighthouse is 4 degrees. This angle is way bigger than 4 degrees. It's okay. The question says, what is the ship's horizontal distance to the base of the lighthouse or the shore? All right, so horizontal distance, right? Horizontal line. Boop, 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 boop. This is what I'm looking for. I'm going to call it X. You can call it something else if you want. Us math teachers, we get stuck in our ways. Now, you probably thought trigonometry was hard before you started doing it, but now you can do it. The hard part might be drawing the picture, maybe. All right. So now I'm going to set up a trig function to find x. All right, what do I have? I'm standing at 4 degrees. So this is my hypotenuse. This is my opposite. This is my adjacent. That's way better than mine. I need a lesson. All right. So let's see. I have the opposite. I'm looking for the adjacent, okay? Then I'm asking myself, which trig function uses the opposite and the adjacent? Opposite, adjacent, opposite, and adjacent. If you don't have it written on your paper, right, maybe you have SOHCAHTOA written on the top. Maybe not. Opposite and adjacent is going to be the tangent. So the tangent of the angle is equal to... So the opposite goes on top, and the adjacent goes on the bottom. Why does everybody's lighthouse look better than mine? Man, we're on number 7, honey. Yeah. Yes, looks great. See, everybody knows what a lighthouse looks like but me. All right, it's fine. Mine's like a spotlight. All right, so how do we solve? We crisscross multiply. I get x times the tangent of 4. 4 is such a small degree. And then 150 times 1. Same story here. I need to get x by itself, so to do that, I'm going to divide by the tangent of 4 on one side and then the other. Now, there's more than one right way to work these out, okay? You could have technically found this angle over by the lighthouse and then worked your way down. That's okay. Most people would just start at the angle that's given. 150 divided by tangent of 4. So some calculator work for you. And we get a big number, which totally makes sense. If across from 4 degrees is 150, then across from this much larger angle, this is actually going to be 86, should be a much bigger number. So that kind of tracks with what we're seeing here. All right. What was the question it asked me? What is the ship's horizontal distance from the lighthouse and the shore? Okay, so the ship is 2,145 point, round to the nearest tenth, so this is going to be 0.1 feet from the, you could say shore or lighthouse, or, you know, however you want to state it. How are we doing? Any questions I can answer? Anything I can re-explain? I don't think anybody like thinks word problems are the best. They're their favorite, so we'll all just like get through it together. This one's kind of interesting actually, because it would be much easier to actually measure the height and the angle than it would be to measure the distance. So like, okay, I feel it. It's possible. Possible that you might need to do this calculation in the real world. All right. And then one more. All right. Read it the first time through for some context. From a hot air balloon. I don't know how to say this name. I've never heard this name before. Janelys? Anybody know? I don't know. Person measures a 33-degree angle of depression to a landmark that's 1,486 feet away, measuring horizontally. What is the balloon's vertical distance above the ground? Round your answer to the nearest hundredth of a foot if necessary. Okay. Here we go. I need a hot air balloon. All right, so hot air balloon. It's got a basket. Right, it's probably got some strings. It's got a balloon. Right. And there is a person in the balloon. From a hot air balloon, Janelys, maybe, measures a 33-degree angle of depression to a landmark that's 1,486 feet away. Some landmark. I don't know what that landmark is, y'all. I'm going to make it a sign because I don't want to draw something too elaborate. Look, there's a landmark over there. Wow. All right, now angle of depression is usually the one that's confusing. Angle of depression, right? So my eyesight is here. When I'm looking down, I'm talking about this angle. So I'm going to draw a line out and then a line down. That angle is 33 degrees. Make it a right triangle. Measuring horizontally, the landmark is 1,486 feet away. Measuring horizontal, so go for the horizontal distance. What is the balloon's vertical distance above the ground? So vertical, what is the vertical distance? When we're doing angle of elevation, you really only need one triangle, but sometimes you'll see two of them. So sometimes the illustrator might complete this by drawing a second triangle. And this second triangle, because this is a rectangle, right, this is still X, this is still 1,486, this would be 33 degrees, this would be the right angle. It's the same triangle, it's just twisted. You don't actually need the green triangle. You could just use the blue triangle if that feels like a lot. But sometimes you might see two and be like, whoa, why is there two triangles there? Just solve one. Okay, I'm going to go back to my blue triangle. I'm at 33 degrees. That's where my person is. That's my reference angle. Where is X? It is opposite. Where is 1486? It's adjacent. The function that uses opposite and adjacent is tangent. So the tangent of the angle is equal to the opposite divided by the adjacent. In my last two examples, my variable ended up being in the denominator of my fraction. This time it's in the numerator. So solving is going to look a little different. I'm going to put my tangent of 33 over 1, crisscross multiply. And when I crisscross multiply, that's actually the only step I need to do. I don't have to do another step to solve for x because x is already by itself. So then in my calculator, I will punch in 1,486 times the tangent of 33. And we get a value for x. In these directions, it asks me to round to the nearest hundredth. And so when I write my answer, I'm going to round to 2 decimal places. All right, 0.01, and then the 9 is going to round the 1 up to a 2. So the balloon's vertical distance, the balloon, is 965.02 feet above the ground. And there you have it. Hopefully they feel doable. Are there questions on this one that you'd like to ask before I shut this down? Feels good. Hopefully that's enough to practice with.